Wow! Hello my dear friends, you are welcome to Joe Newton online class. In this video, we are working on mathematics and we have an indices task on the board. We are asked to simplify this task. Good. It appears to be difficult, but you can see how simple it is. See the options here. We will get the right answer, we shall know. Now, solution. The first thing we have to do here is to solve the inner square root. Of course, you know mathematically, if you have x raised to power 1 over 2, it means square root of what? X. Right? So with this knowledge, we continue. So this will give us cube root of 729 raised to power 1 over 2 times y raised to power minus 6 then to power 1 over 2. You know, these expressions are the same. So this raised to power 1 over 2 is for all of them, according to law of indices. But this minus 6, raised to power minus 6 is for y alone. Be mindful of this. So this is for y alone, but the outside here is for both the number and the letter. So I have just separated them. Okay, that will give us cube root of, now 729 raised to power 1 over 2 simply means square root of 729. Of course, that will give us square root of 729 then times, here we have 2 here, 2 here, we get 3. So times y raised to power minus 3. This is what we have here. Because this y raised to power minus 6 raised to power 1 over 2, it means 2 divided itself, 2 divided itself 3 here. So minus 3 times 1 minus 3. Then that will give us cube root of square root of 729 is 27. You can believe with me that 27 times 27 gives us 729. 7 times 7 is 49, right? 9 carry 4. 7 times 2 is 14. Then plus 4 have 18. Then you have that is 7 times 7, 49, right? 9 carry 4. 7 times 2, 14, plus 4, 18. 2 times 7 is 14. Right? 4 carry 1. 2 times 2, you have 4 plus 1, 5. And that will give us here, you have 9. And here, you have 12. You carry 1, put here, you have what? 7. So 27 times 27, that means 27 square is equals to this, equals 729. So square root of 729 is 27. Then times y square, y raised to power minus 3 will give us 27y power minus 3. Very simple. Then further, we have, then this implies, in other words, 27y raised to power minus 3 into 1 over 3 to power 1 over 3. Because mathematically, if you have cube root of x, it simply means x raised to power 1 over 3. By indices rule, it simply means x to power 1 over 3. That is cube root of x. So applying it here, this will transform into 27y power minus 3 all to power 1 over 3. Good. Now, this simply implies, cube root of 27 then times 3 cancel itself here, 3 cancel y here, 3 here, get minus 1. So times y power minus 1. That's what we have. Because this power minus 3 cancel itself here, 3 cancel this one, 1. Then this 1 over 3 here to here means cube root of 27. Very simple. Then when you expand it, which gives us cube root of 27 is 3, because 3 to power 3 will give us 3 into 3 places. 3 times 3 is 9, 9 times 3 is 27. So this will give us what? 3. Then 3 times y raised to power minus 1 will give us 3 y raised to power minus 1. In other words, by indices rule, if you have x raised to power minus 1, it transforms into 1 over what? X. It will be something like this. So with this knowledge, applying it here, we will now have 3 times y raised to power minus 1 means 3 times 1 over y, which means 3 times 1 over y, giving us 3 over y finally. So our final answer is 3 over y. So our answer is 3 over y. Now look at the options. The correct option here is option D. This is the correct option, 3 over y. So not because this raised to power minus 1 is only for this y. 3 is not involved because there's no bracket covering all of them, covering both of them to power of minus 1. So it is exclusive for this y, and we apply this rule, we are left with 3 over what? Y. Thank you so much. You can see how to, the method or the procedure or the principles or the rules in tackling this kind of indices that it seems to be challenging. You follow it, treat the inner indices well first, then you operate the final, do the final operation at last after you have, and you should be able to know the implication of these powers, in indical expression or in indices. So once you master laws of indices, you will not find it difficult to solve this type of task. Thank you for paying attention to this class. I believe with this you can tackle similar problems involving indices. For more of these solutions on mathematics and physics, then visit my YouTube channel at Joe Newton Online Class. There you subscribe for notifications, share, like, and even comment. Drop your questions there. Then visit my Facebook page as well and follow and like. Thank you.